So in the acid-base lab, we are going to need base, and this is our sodium hydroxide, and this is the molarity. You want to write this number down on your sheet. This is what we're going to be putting in our burettes. Over here, this is our hydrochloric acid. This is what we're going to be putting in our Erlenmeyer flasks. This is the acid that the base is going to do a reaction with in the flask. Notice that hydrochloric acid has one H. And then over here, we're going to do it again. And this time, we've got phosphoric acid, and notice that there's 3 H's. In both acid cases, notice we haven't given you the concentration. That's what you're going to figure out. So these two, we're going to be running 3 trials each time. I've got this one for an example. So we're going to have a lot of data to make sure we've got good calculations. So it's hard to see a reaction if everything is colorless. So we use this. This is phenolphthalein, and it looks colorless, but once the reaction occurs, it's going to be pink. So we're going to know, and there's a special point you're going to see, when we know that everything in the flask is reacted, the flask is going to be a very light shade of pink. We're also going to be using a buret. So again, this is where the base is going to go in, and we always use a funnel when we're putting the base in the buret. And then over here we have pipettes, and these pipettes are going to give us a very, very good quantity. It's going to be very precise. This is the 10 mil, this is the 20 mil. We're going to use the 20 mil with the HCl, and that's the first run we're doing. We're going to use the 10 mil with the phosphoric acid, the H3PO4, and that's the second series of reactions that we're doing. We're also using pipette bulbs, and that's what we're going to use to get the suction to get the acid drawn up into these pipettes. And just as a note, in labs and other situations, it's not always a bulb that people will be using, but a bulb is a great place to learn how to use pipettes and to start. So with the titrations, we've got to have something in our buret. So the first thing I'm going to put in is the sodium hydroxide. So let's say that I want to get this from here to here. One thing I've got to use is a funnel. This is a type of base, and bases aren't great on your skin. They aren't great to spill places. So I definitely want to use my funnel right here. I'm going to put it in here. Now you'll notice, see how tall this is? Like it's just going to be awkward for me to pour into that. That's fine. Just make sure that you just change where your buret is. Let's say if I want, I can even move it like this to make it a little easier for me to be able to reach the top. And then I can change it back around. So I'm just pointing out there's some different ways that you can do it. Just make sure that this is comfortable where you're pouring the base in. The other thing is that when we get this out of here, it's not a good idea to just stick something in here to try to get it out, or to try to pour from your stock solution. It doesn't have the lip on it. So I'm going to pour into my beaker. Also, there's a whole lot in here, right? So I don't know, if I were to make some mistake and spill it, I'd spill a whole lot of it versus just a little bit. So again, I'm going to fill this. Remember that the funnel drains more slowly than the buret. Also, I want to point out, this is horizontal. Horizontal means it's not going to go through. It means that the hole is closed. When it goes vertical, if I'd had this vertical, it would be draining out the bottom of it. So I'm going to keep filling it. If you can tell where it is, you'll notice, see, I'm just doing it in parts because I don't want to accidentally overflow it. Now this is fine. You don't have to have it filled again to the exact 0 mark. You don't have to fill it. You just want it to be filled to somewhere near to the top. And if we zoom in, if you come in close, you can see there's a little air bubble right here, and there's an air bubble right here. What we want is this to be all the way filled with sodium hydroxide. So I'm going to drain it all out. Now you can see that they're all gone. I know it looks like there's a little teeny tiny one there. I think that's a glassware defect.